Okay, this got me a little confused at first, but I posted this one time. This is my second time posting it. I believe that if you can have three congruent to three, which would be nine, and four congruent to up to the parentheses of time, which would be one of light, and the parenthesis up to pi, and then or subtraction of pi, and then the congruency of wavelength of a congruent wavelength. You should be able to put something underneath it so you don't have to divide it or cross multiply or anything like that. So I put force minus motion multiplied by wavelength congruent to half a wavelength minus momentum, and it should be plus momentum, I think. Plus momentum or minus momentum, I'm not, I'll have to, I think it's minus momentum actually. I think I wrote it right. And congruent to inside kinetics plus mass. And then you multiply that, but that's already like acceleration. That's already like acceleration. Compared to force of motion on top minus mass, or force plus motion minus mass, that seems like acceleration too. So then I multiplied by acceleration and I congruentized it to phi gravitational pull of a known object in space, and I put in parentheses. I think it should be omega times alpha. And then so when I'm looking at this, I kind of tried to mess with time in a way that would be easier to understand. So I think that this is actually a good way in showing how magnetism plays a big part in the universe. Because if you need a paradox of magnetism, you wind up with something like this with knots at each corner. You have a knot down there, a triangle down here, and this is a wavelength to go through, and another knot down there, and a hexagon down there in the corner that I'm not sure of what does, but it seems like it's out of Guardians of the Galaxy, sort of, so to say. But there's a mass right here, and there's an angle right there to direct the mass to where you want to be, where it's at when it is where it is. So it's not impossible to do this, but it just seems like it's improbable that you can't put the things over each other that are in there. Now this one right here, I made, that's a continuum. This is my golden constant. This is negative h bar squared. This is the light that I made up. If I was wrong on light, I might be right later. So stick with it and see about checking it out. This is time displacement. So really, it starts why time displacement has a t in it is because it starts with this. It starts with Newtonian time. And then it doesn't have space and time in it, but it could be space and time dilation. The reason why is that it shows space and time at the end. The other thing is that I put T dot D with a bar over it because it could beat times expansion of time squared, and then I put H bar conjugative to phi congruent. I'm pretty sure I put that the parentheses in there right, and the brackets in there right before I subtracted pi, congruent to a congruency of a wavelength. So all in all, you do get an equation, and I'll show you where I stopped. Was somewhere right here, right there, and it was a wavelength this way. But as you can see, the frequencies didn't get touched by the wavelength. They got bumped up and shot down one time, and it hit just one little frequency. One little frequency hit it and put it back to where it was over here. As x to x. If I were to put if I were to put x to x at the end of alpha, I'm trying. Let me think. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't even do it. I can't even do it. I would have to get rid of omega, because that's the loose end. I don't want to get rid of omega. I'll get rid of alpha, and I'll put in x comma x. X in the derivative of x. So then after that, x in the derivative of x, because alpha was a good thing for it. X in the derivative of x shoots down this way, comes over here, and gets tied in the knot right here, and shoots around this way, and stops right here, and gets shot up right up here, all the way to the third part of knowing where the bottom of the mass is in magnetism to the parallels paradox. And then you can sense that there is a polar differential between you or some other planet. And then after that, you would land on said planet in a certain area on the two angles that are right here and right here. So you would land directly in the middle, keeping you safe from any harm of a frosted planet, or if it were a fiery planet, it means that, gaseous. It'd be a lot easier to understand if you knew, I guess, the planets, or any planet or anything about planets. But I'm not an expert in that field, so I don't bother about it, and that's all I can say about that. So I'll see you guys when I see you. And just to get the thing straight about what I said, this is magnetism's paradox, which is it's basically the opposite of light with a bit of force involved. So then I congruentize that to force plus motion minus mass. Down here, light times time squared, or light plus time squared. Then this was space-time x, xy, time displacement, Newtonian time, x squared, negative pi, h bar, phi, congruency of the congruent to the congruency of the wavelength. Then back over here was force minus motion, wavelength congruent to half a wavelength, and that helped out a lot. But I don't even know if that counts as 1 though. I'm not sure, and if it doesn't, I'm glad that I used the x at the end. What I can find out about the momentum is after the wavelength, it goes up to here, and you should track momentum. X goes right here, goes down here, goes there, and kinetics plus mass. Why does it still miss the frequency? See how it bounces around the frequencies? Then the mass starts off right here. Okay, and then acceleration. Acceleration would be still going this way like that. Gravitational pull of a planet. Basically that. Then omega. Because I'm not sure if I can use it many in my equation. I'll just try to use it. But this should be the end of the answer, actually. And I'm not sure why I put omega and x1 and xy, but it should be the end of the equation. So I'll just cross all that off, and this is what it comes out to be. All right. So thank you. All right. Thank you. Bye.